Hi guys, welcome to Tech Combos YouTube channel. Today we are going to cover variables in C programming. In previous video we have seen about history of C and the need of the variable. Today we are going to see in detail what is the variable and its related details. For this session we have taken two variables as an example and both of the variable data type is different. One is a character variable and another one is an integer variable. Character small a equal to capital A and int b is equal to 65. For a specific example only, I have taken these values. If you look at earlier, we have learned about ASCII values. What is ASCII value means? An integer value of a respective symbol. You have already seen in computer every information is stored as a binary number, which is nothing but an integer value. Computers cannot directly understand the character and floating point number easily. But internally, according to the data stored in the memory, system understand that as a character, float, etc. If you look at character A is equal to A, though this is a character variable, but this value would be considered or treated as an integer internally. And ASCII value of capital A is 65. Int b is equal to 65 and it will be directly considered as a integer by the system. If you look at, since the integer value of both variable a and b is 65, its binary notation also same. The binary notation for 65 is 1 0 0 0 0 0 1. Variables are nothing but named memory locations. We have already learned that everything on the computer are stored and processed through the memory. Whenever we use different variables, it would be stored in different memory locations. It's very tedious task to refer the memory by its own number. For that reason only variables are used to refer the memory locations and it's making human to easily refer the memory. For example, if you look at the memory locations like 0010, 01001 is very hard for a human to remember and manage. That's the reason we have this human readable notation to point the memory location. It is nothing but giving or mapping the naming to a computer's memory location. That's the reason we call variable as a named memory location. Whenever we talk about a variable, you should remember that it has named memory location. If you look at, you can visualize any variable as a box or a container. And whatever the box or a container contains is called the value of the variable. In other words, the variable is holding that value. Now you are looking at the random access memory. In this, we are having sequence of memory bytes. In program, whenever we declare the variables, then according to the data of the variable, system will reserve the respective number of memory in the random access memory. In our example, the variable small a is a character variable. It requires 1 byte of memory. Due to this, you can see in the random access memory, 1 byte got reserved. Now, if you look at the variable a is pointing to the location 1000 in the memory. In the memory location 1000, our variable got stored. If you look at the number 1000 is a value of the location. I mean address of the location. It is a 1 byte data. In that, how the data stored is as like this. We have already seen the ASCII value of capital A is 65 and the binary equivalent to 65 is 1 0 0 0 0 0 1. That's what got stored in 1 byte memory location. Now we will talk about the next container, which is the variable b. The type of a variable b is an integer. If I consider the variable b as a container, you can see inside that container the value 65. If you look at for the data type integer, normally an integer variable in Windows 2 bytes are reserved, in Unix system 4 bytes are reserved. Now variable b 65 value is stored in the memory location 1001. And we have seen for integer, we require 2 bytes. So the memory location 1001 plus 1, 1002, like this, the memory reserved for the variable b is 1001 and 1002. You can represent integer using 2 bytes of memory location. That's what you are looking at now. This is how in the system variables are being stored and represented in the memory. Additionally, I would like to share one more information about the symbol table. What a symbol table means. Normally, whenever you declare and use variables and functions in any programming language, these are stored in the symbol table. Quickly, in program, identifiers like variables name, function names are called symbols. These symbols are maintained in the data structure called symbol table. The symbol table is used for referencing the variable, like knowing the type of a variable, what's the scope of the variable, etc. Also, most of the time, whenever we write a program, we use predefined functions or any variables belongs to another predefined library, which will not have any definition on the current source code file. In such cases, during compilation, these symbols are considered as a undefined symbols. At the time of target file creation, which can be an object or executable file, the linker will understand that these are undefined symbols and it will try to look for actual definition from external libraries, and it will assign the reference in the symbol table to change the undefined symbol as a defined symbol. Ultimately, the important task of a linker is to find the references of all the undefined symbols and update the symbol table accordingly. We can now practically see the example, whatever we have seen so far in the presentation. I have written a program test1.c. If you look at the program, whatever variables we used in the presentation, the same variable declarations I have used in this program. Character small a is equal to capital A, int b is equal to 65. If you look at the objective of the program is to, along with displaying the value of the character variable small a and integer variable small b, we are also going to display the character variable a as an integer. In the presentation, we have seen that the variable a and b's binary notation is same, since both the variables having the value 65. We can practically see that in this program output that the value of both variable a and b as an integer is same in this program. So cc test1.c -o test1 test1. If you look at, you can easily understand that first two lines, that is the value of a character as capital A and the value of b int as 65. It's correctly displayed. So at the same time, while displaying the variable a as an integer shows the value 65. So this is what I would like to show to you. Now we have seen the variable and its value and how to display the value of the variable. As part of the next example, in that program, we are trying to display the address of each variable. If you look at how to take the address of variable is by using the symbol ampersand together with the variable name. The detail about the address we can see at the time of learning C pointers. As of now, you can simply understand that ampersand is used for getting the address of a variable, where ampersand a means address of a. If you look at, the aim of this program is to showcase how much memory is taken by each variable. Now I am executing the program cc test.c-o test. So if you look at, the address of a is ending with 1f and the other two variables address is ending with 1e and 1d. You see the sequence of this variable AAA's address ending with 1D, variable AA's address ending with 1E. You can see memory address is incremented by 1. We have seen that the memory size of the character variable is 1 byte. That's the reason you can see it's getting incremented by 1. The value you are looking at this is hexadecimal value. So the value E is coming after D. We have learned that the hexadecimal values has 16 values, that is 1 to 10, and A, B, C, D, E, F. Now you can easily understand that the character variable's address is incremented by 1. Now we will see now we will see the integer variable. If you look at this, let's start from the variable d, and the address is ending with f10. I have already mentioned that the memory needed for storing the integer is 4 bytes. So 10 plus 4 14. Next variable 14 plus 4 18. Like this, memory got allocated. I would like to share one more additional information that people call C as a stack based programming or stack based programming language. That means everything works on the stack. Related to that, we can see the detailed information later. I will explain once I get the chance. If you look at this, you will get one question in your mind. What that question is, like, A's address should have been entered with 1D. A's address should have been entered with 1E, and AAA's address should have been entered with 1F, but it's in reverse order. Likewise, B should have been 10, C should have been 14, D should have been 18. Let me explain. If you look at the program with respect to C programming, everything is pushed into stack and it's been processed. If you don't know what stack, then in short, it's a data structure and it is called first in, first out. We will try to cover the detailed session about this while covering the data structure session in the later in point time. As of now, we can simply understand that C is a stack-based programming language. What I am coming to say is that in the program, each variable declaration statement works in right to left order fashion. It means the C compiler will push the variable AAA first, then AA, after that A. Like this, C compiler navigates from rightmost position and it will allocate this and this and this and this and this and this. Like this only, it will allocate. That's the reason you saw the address in the reverse order in the program output. I guess you would have got a fair idea about the variable. Thank you so much for watching the video. I will get back to you with another video. Thank you.